Hello everyone, welcome to the latest RxM Cloud Native Short Take. My name is Christian Laksina, and today we'll short take the RxM Kubernetes block storage module. In this module, we introduce the container storage initiative. We'll then talk about the evolution of dynamic storage provisioning for Kubernetes. We'll present examples and use cases of CSI plugins, and we'll demonstrate the use of CSI plugins in Kubernetes. For this short takes demo, I'm going to demonstrate the steps required to enable dynamic block storage provisioning for my cluster using AWS EBS. My cluster consists of a single node Kubernetes cluster, and in order to set up dynamic provisioning, I first need to set up my CSI plugin. A CSI plugin on Kubernetes provides a provisioner, which runs on the cluster. It's the provisioner's job to realize my requests for storage using the chosen backend for my storage, in this case, AWS EBS. To do this, the provisioner must have credentials, which are ideally provided by a Kubernetes secret. For AWS EBS, I needed to provide a valid API identity and access key, which I've already loaded onto my cluster. Next, I need to deploy the provisioner itself and its supporting components. The provisioner itself runs as pods on the cluster, with a managing controller running as a deployment and a daemon set running a pod on every node in the cluster that ensures the created volumes are properly attached to each node. RBAC elements are also included to ensure the provisioner can communicate with the API server. Finally, a CSI driver resource enables the Kubernetes persistent volume subsystem to identify the driver. With the provisioner deployed, I need to create a storage class resource that enables my persistent volume claims to use the provisioner. This storage class identifies the provisioner using the name established by the CSI driver resource created earlier. I'll go ahead and apply it to my cluster now. Now that I have my storage class in place, I can create a PVC that uses the EBS CSI driver. The key line in this PVC is the storage class name. The storage class name refers to my EBS SE storage class, which uses the AWS EBS CSI driver. Once I apply this PVC to the cluster, it will soon bind to a brand new PV automatically. Go ahead and establish a watch for persistent volumes and persistent volume claims. And I will then apply my PVC. We can see the PVC is created. It's in a pending state, and shortly after, a persistent volume is created. During this process, the provisioner reaches out to the EBS subsystem on AWS itself, tells it to create a PV, or rather, tells it to create a block storage device on EBS, which best fulfills my request for storage. Depending on the storage backend, you might see slight differences between your request and the provisioned PV. AWS EBS has a minimum volume size of 1 gigabyte. So my initial request for 512 megabytes was fulfilled with a 1 gigabyte volume. And that's it. Any PVC applied to the cluster using the storage class will automatically provision an EBS block storage device for itself. The use of block storage devices on Kubernetes is just one of the things you'll learn in the Kubernetes block storage module from RxM. You can create your own customized Kubernetes courses with this and many other modules using the courseware builder on the RxM website, rxm.com. Once you get to the website, go under courses and you can find the custom courseware builder. In the custom course builder, you can scroll down and find the block storage module under Kubernetes, drag it over to your custom course, and along with other modules in the RxM catalog, you can create a customized Kubernetes course that fits your needs. That's our cloud native short take on the Kubernetes block storage module. Thank you for watching.